Hi there, I'm Hao, and this is just another video of me solving randomly code problem by research tree iterator. So we need to implement a BST iterator class that represent an iterator over a binary search tree. So which is in order traversal. So this is our constructor here. We need an object class. The root is given in the argument in the parameters of the constructor. Right, and we have the hasnet which return true if there exists a number in the traversal to the right of the pointer. Otherwise, we can return false. The next, move the pointer to the right and return the number at the pointer. Okay, so a pretty straightforward to do this is that when we initialize the tree, we can store it in we can traverse, right? So in order to traverse the binary search tree, right, we have to traverse in the in order manner, right? So we're gonna have like 3, 7, 9, 15, and then 20, right? We can store it in our structure and then keep track of the index, right? So every time we do the next, right, we can move on to increment the index to the next number. So let's say we have the next here, right? We'll return 3, right? And our index will increment to 7, right? The next here gonna return 7, right? And our I gonna increment to the next number, right? Has not gonna return true because I is less than the length, right, of the array. Right. Next again, return 9 and increment to the next number. Right, has not return true because I is less than the length. Next here, return 15, increment I to the next number. Has not here return true because I is less than the length. And has next here, the next here, return 20 and increment I. Right now has that return false because the I is out of bound. Right. So using it this way, setting it up this way, we can do the next or has next function in constant time, right? But we need extra memory space to store the sorted array. Okay, so let's code this up. So first thing first, our constructor here, we are given the root, right? And then we need to store them in a sorted node. Right? And so let you add the array by calling the in order traversal, passing in the root here, and we need our index starting now at 0. If there's no roots, we can return. Right? Otherwise, you're gonna process the left, process the root, right? Then process the right, right? The in order is we gonna always process the left first, then the root, then the right. Okay. So after we call this function, we're gonna have the sorted node array gonna be built out, right, in the in order traversal manner, right? And then we have our index starting out at 0. So if the next is being called, we will return the value at the current index, right? So this is our sorted node, and this is index. Right? So when the next is called, we're gonna return the value as the current index, right? And then we need to increment our index. For the hash next, we have to return is the index, or the index is still inbound, right? So if it is less than the length, it is inbound. If it is equal to the length or richer, which means we have run out of node, right? And we are at the end of the iterator. Okay, so let's try this. accepted. So thank you for watching.